Hello everyone, and welcome back to Blockchain Community Day. I'm thrilled to announce our first speaker, someone who truly understands what it means to operate at Web3 scale. First things first, I'm Farouk. I'm gonna be your moderator for the whole conference. Managing a single blockchain is already a challenge, but what about 60, 70 plus chains? That's exactly what we're about to explore. Please welcome Dr. Ravi Chamria, co-founder and CEO of Zeeve, India's leading no-code blockchain infrastructure as a service platform, empowering over 30,000 users throughout the world. Correct me if I'm wrong, Mr. Ravi.
No, absolutely.
The floor is totally yours. Let's dive in.
Yeah. Can you see my screen properly, like the full screen?
We can see it perfectly.
Okay, thank you. Yeah, hi everyone. My name is Ravi. I'm the co-founder CEO of Zeeve. And first of all, before I get started, I would like to thank WeAreCommunity. It's an amazing initiative that they have, and it's a pretty amazing conference that they have set up with incredible lineup of speakers and builders in Web3 space. And we at Zeeve are very, very excited to partner with WeAreCommunity to be part of this conference. So thanks once again to WeAreCommunity. Now, the topic which I'm covering today is managing Appchain infrastructure at scale. So first, let's understand what Appchains are. So we have seen the enterprise adoption, which started happening in 2016-17 with some of the permission protocols like Hyperledger, Fabric, Besu. Then R3 Coda came in as a bank consortium. And then quite a few other stacks. So all the enterprises, typically, they were launching a consortium network or a network of their own based on a certain application. So for example, somebody wants to launch a trade finance platform. And along with that, they want to have their own blockchain. So we call this an app chain, an application-specific blockchain. So on the enterprise side, we had some of the permission stacks like Fabric Besu. And on the other hand, even in the public domain, we were seeing a lot of L1s coming into picture. And when we say L1s, I mean layer one blockchains, public chains that people were launching. And some of them were general purpose chains. So general purpose chain, you could take an example of, for example, Ethereum or Polygon POS or Binance Smart Chain. These are general purpose public chains or L1s on which, any developer can go, they can deploy their smart contract, they can deploy their dApps and start using it. On the other hand, there are quite a few app chains, and app chains means you're launching a platform specific to an application. Now, examples could be anything. Somebody launching a trade finance platform like they were Marco Polo, or in any other domain. So we see a massive amount of app chains. So the whole concept of app chains is application-specific chains where you have your own layer one chain, and it is specific to an application or a set of applications within a domain, like, for example, Injective focused on financial applications. So that is what we mean by app chains. Now, why app chains have suddenly become such a rage in last 2-3 years? And this, I think, is a natural progression. So we saw that there are lots and lots of dApps being deployed on public chains like Ethereum. But then what happens as your dApp grows and you start having more transactions, more users as part of your community, then in that case, you start fighting or competing for block space on the public chain. And it may lead to higher gas prices, as we have seen in quite a few incidences where, based on a new NFT project launch or a gaming project launch, suddenly the gas prices spiked up. So, but when you are launching your own application-specific chain, what you want complete control over the user experience. And for that to happen, you need to have your own set of configurations, or you want to have control over throughput, you want to control over gas economics, and so on and so forth. So that is why AppChains started picking up, and a lot of people started launching their own AppChains. But one of the major challenge at that time was there were no proper stacks to launch an AppChain. Forking a code, which was a normal norm at that time, taking Ethereum fork or Lisk fork, it was a nightmare because these code bases were not written to be replicated, and that's why it was very difficult to fork a chain and create your own L1 or your app chain. Then came the stacks, proper stacks that you can use to launch. So first we saw the advent of some of the app chain stacks like Cosmos SDK or Avalanche subnets, and then substrate parachains, where you can use some of these stacks and launch your own sovereign chain. And then 2 years back came the concept of rollups. Again, using rollup stacks like OP Stack or Arbitrum Orbit, you can launch your own app chain. Specifically called rollup, but it falls under the general category of app chain. So this is basically the reason why app chains have become more and more important, and why we are seeing lots and lots of builders launching their own app chains and rollups. According to RootScan, a recent report which was released about a few weeks back, out of almost 2,000 active chains, 70% are app chains or modular rollups across layer 1, layer 2, or layer 3. And this is significant. So we are seeing that there's a massive advent of builders launching their own app chains. And most of this has been powered by some of the stacks which I just mentioned. So what AppChains provides? One, it provides superior user experience. And user experience encompasses all the desired characteristics, whether you want to have your own custom configurations. If you're launching an enterprise chain and you want to have compliances, you want to have data compliances or adherence to regulations, or you require high throughput, or you require a different kind of consensus or governance model. So all this is possible only when you have full control over the underlying chain. And that's why app chains can be considered as the future of Web3. Now, in terms of evolving landscape, these are some of the primary stacks that I mentioned about. So if you want to launch an optimistic rollup, you have OP Stack and Arbitrum Orbit, primary optimistic rollup stacks. And then we have zk stacks like zkSync. And then we have typical app chain stacks, launching your own sovereign L1s, where we have Cosmos SDK, a massive ecosystem of Cosmos, where Cosmos is a hub and you can create your spoke chains. It can be a completely independent sovereign L1 using Cosmos SDK, or you can still connect with other chains within the Cosmos ecosystem through using various interoperability tools. Similarly, we have Avalanche subnets, which has now been rebranded as Avalanche L1s. So you can launch your own sovereign L1s using Avalanche L1 stack. And the best part is you can launch from complete permissionless chain to a permission chain. And then, we have parachains. You can use Substrate framework to launch your own parachains. So these are primary stacks which, constitute the app chain landscape today. Our journey, we have been in launching app chains and rollups for more than 4 years now. And our journey has been, we started with enterprise protocols like Fabric Besu, helped quite a few enterprises launch their blockchain applications using a complete permission stack, highly secured, compliant, etc. And then we started seeing this trend of launching app chains in the public Web3 space as well. And that's where, we partnered with some of these stacks and started offering app chains to different customers. And today we are running almost 70 plus production app chains for various customers across various stacks, and almost 350 plus testnets. And in our journey, there has been a massive amount of learning, which I'm here to share today. And we realized that, launching your own app chain, especially getting the same kind of experience when you deploy your dApp on a public chain, it should be similar. It was not 4 years back when, people were forking Ethereum fork or Bitcoin fork or different other protocols. It used to take hundreds of thousands of dollars to build such a platform. And at the same time, there was a massive cost of infrastructure, managing it, and there were massive overheads. And once these stacks came in, we started investing into these stacks and created a whole set of infrastructure tools to ensure that launching an app chain is as easy as launching a smart contract. So now coming to the main topic as to what we have learned, what have been our learning. So what are the major challenges when you talk about your own app chain? Now, just to differentiate further, when you are launching a smart contract on a public chain, the desired infrastructure is already there. You simply need to deploy your dApp, you need to deploy your smart contracts, and you may need to use some of the third-party integrations, which are already available on that public chain. So if you want to use Interop, or you want to use, let's say, decentralized oracles from Chainlink or Redstone, you can simply plug in because their support is already on that public chain. But when you launch your own app chain, then you need to take care of each and every aspect of it. It gives you a lot of flexibility, independence, control, but at the same time, you require to manage the entire infrastructure yourself. So that is the downside of it, and that is where we come in. So first is the launch phase, where you need to understand what kind of custom configurations you require depending on your use case. If it's a DeFi use case, you may require high throughput. If it's an enterprise use case in the financial services space, you may require strict data compliances, or let's say in healthcare, or it's a payment use case, so very, very high throughput and scalability, because infrastructure demand can go up and down anytime. So depending on your use case, you do require a lot of custom configs. So that becomes a challenge because once you set the configurations, many of the configurations cannot be changed later, as you can do in a case of a public chain. That is not true when you talk about an app chain. And then, of course, you need to have a very solid infrastructure, high availability of nodes and the sequencers and validators, all different kind of node infrastructure. And then validator onboarding, especially if you are launching, let's say, a POA-based chain. You may have a consortium where you want to have a permissioned onboarding. Or let's say you have a POS-based public chain. You still want to make it easy for the validators to join your chain. And then smart contract versioning, etc. So these are some of the pieces that you need to take care when you are launching your chain. The second phase is operations and lifecycle management. Now that becomes very important because now you need to take care of the chain upgrades and all the maintenance overheads. So newer updates, because all these stacks are like piece of software where continuous upgrades and updates will continue to happen. So you need to ensure that your chain always updates and upgrades whenever a new version is there. And then, of course, security and decentralization trade-offs. You need to be very clear as to, depending on the use case, depending on your requirements, how much security and compliances need to be there, how much decentralization needs to be there, and accordingly choose the right stack and configure it properly. And then highly scalable infra, where on-demand scaling can happen. At the same time, you also need to ensure that your infrastructure is not just highly available, but well distributed across the globe, so that there are, it leads to higher decentralization, at the same time, lesser risk and more security. And the third phase is reliability and support. Once you have launched your chain, now you want a very solid management dashboard and monitoring capabilities, so that you can monitor the chain, all your nodes, etc., so that you can be ensured that all the performance criteria are being met and the user experience is top notch. And then, of course, it needs to have a very strict SLAs, different kind of observability tooling. And then in addition to that, you also may require different third parties integrations, whether it be account abstraction or interoperability or oracles. So you need to take care of all these different pieces as well. And so based on these challenges, what are the best practices of creating your own app chain with a highly scalable and reliable node infrastructure? So first is automate the bootstrapping of nodes. So as I mentioned, depending on whether you're launching a POA, POS, or any other different kind of consensus chains, depending on how permissionless or permissioned it is, you may require bootstrapping of nodes. So why we created one-click testnet? The only reason is not just to bring in high level of automation and reducing human errors, but at the same time, while you are launching your testnet, at the same time, you may require some iterations. let's say you did some initial configs, launch your testnet, and then tried your use case, tried your smart contracts, and then you did some kind of benchmarking based on performance matrix and other metrics, and you realize that, okay, we need to fine tune the configs again. So that's why you require that testnets can be created again and again on the fly, and it should be very easy to launch a testnet. Then pre-integrate core components. So when you launch your chain, there are certain set of core components. Like your chain will come up with the set of different kind of nodes. It will come up with a block explorer, because every chain needs to have a block explorer where people can see the transaction confirmation, different transactions, and so on and so forth. Then you also need to have faucet if you're launching a testnet, so that the builders or your own developers can use the faucet to mint tokens and use them while testing out the apps. And you may require some essential bridges, like when you're launching a rollup, you may require an L2 to L1 bridge. Or if you're even launching an app chain using some of the L1 stacks, you still may require interoperability or bridges to bridge some tokens. Maybe your use case demands you to bridge USDC or USDT. So you require all these core components. And then geo redundancy becomes very important, because you want your infra to be highly distributed. And if it's permissionless, you want more and more validators to come in from different areas and become part of your chain. So that again becomes very, very important. Your RPC, public RPC, should be highly performant, at the same time reliable, so that all the dApps which are running on your chain can perform very properly. And then at the same time, you need to have load balancing, active failover, high availability. So all the tenets of high availability, that becomes very, very important. And then one simple thing is use snapshots, so that whenever you are, let's say, if you are upgrading the chain, or you need to create a hard fork because you want to make some major changes in your Genesis configuration, then having a snapshot makes it very easy to resync the chain and so on and so forth. Now, if you talk about the best practices of validator and sequencer, now this is very important, because any chain is decentralized to the extent how their validators are performing. So you need to have good number of validators, and at the same time, those validators must be active. They must be validating the chain properly with high uptime, and so on and so forth. In the case of rollups, there's no concept of validator per se. Instead of that, you have sequencers, and their sequences again become very important, because sequences are the ones which are sequencing the transactions that are happening on the chain, and then passing on, using those transactions, it relays it to data availability layer, or to generate the proofs, whether optimistic proofs or zk proofs. So it's very important to adhere to all the different best practices for managing your validator and sequencer network. So one is, as I mentioned, onboarding access, so that anyone can easily become a validator on your chain. Now, it can be a simple documentation, how to onboard, and people can launch their own validator node on your chain. Or it can be resorting to platform like Zeeve to create one-click validator onboarding, so that even non-technical users can simply make few clicks and launch a validator on your chain. And similarly, same goes for the sequencer, or let's say, in the case of optimistic proofs, verifier nodes. So same as goes for validator nodes in the sovereign L1s. Similarly, having verifier nodes or sequencer, making it very, very easy and highly available. And then version control for consensus upgrades. That is again very, very important, so that whenever a change is happening, the validator binary also needs to be upgraded. So we need to ensure that all the validators have been updated with the newest code base. And in addition to that, having a very solid 24/7 proactive monitoring is very important, so that you can see, because when you are launching a chain at the start, you may have a lesser number of validators. So let's say you start a chain with 8 to 10 validators. Now, for example, in the case of Avalanche L1, if your more than 20% of validator nodes are not active, then your chain may go down. So that's why it is very, very important to ensure that the validators are active and they are performing their job. Then best practices for rollups and upgrades. Again, one is each rollup stack most of the rollup stacks are comparatively new. We can still say that optimistic rollup stacks like OP stack and Arbitrum Orbit are very, very mature. But zk rollup stacks like zkSync, etc., are still in the process of maturing. We are now seeing a lot of production chains coming out of zk stack, but still there are a long way to go. So there are continuous updates and upgrades that happen. So to ensure that whenever there's a release, the release is applied to your chain, which has been built using one of those stacks. Then having orchestrate safe version rollouts, use canary deployments before full rollout, and then manage app layer versioning separately. Again, super important. And then to top it all, have a sound monitoring in place to monitor not just one node type, but RPC nodes, your sequencer nodes, your prover nodes, your verifier nodes, and then your public RPC L2 and L1. Let's say you're creating a L2 roller, then both L2 RPC as well as the L1 RPC. Then monitoring and observability is very, very important, especially as your chain grows. Initially, when you launch an app chain, it may be you maybe end up running all your validators and RPC. Comparatively, it is much easier to manage that kind of infra. But as your chain grows, if it's a permission chain with a consortium, then different consortium members will start setting up the nodes. If it's a permissionless chain, then public nodes will start coming into picture, and there would be public RPC usage as well. So in that case, having a high performance is very, very important. So in this case, having 24/7 monitoring in place, having a proper alerts and notification system so that automatic alerts can come in, and at the same time, some proactive alerts. So depending on, you can define some of the metrics, like if the CPU usage goes beyond 60%, if the memory usage or storage is getting blocked up. So all our bandwidth is getting clogged. So all those kind of alerts and notifications need to be in place so that proper monitoring can happen. So both proactive monitoring as well as 24/7 monitoring becomes very, very important. Now, in terms of SLA and incident management, so SLAs ensures that your chain is always active. It is performing as per the criteria. And at the same time, all updates, upgrades, etc., are being taken place. And this becomes very, very important because today, user experience has been one of the most talked about challenge in the Web3 space. And if you're launching your own app chain, then the entire responsibility of having an amazing user experience falls on you. So that's why having proper SLAs to manage the chain becomes very important. And then automate the incident response, having an L1, L2 support so that all the incidents can be easily managed, whether it be security or non-security incidents. And then create learnings out of each incident that has happened so that the next iteration of chain is much stronger and much, much, much more reliable. I would like to create some case studies here. So Memento zk chain is one of the latest chain that we launched about a few weeks back. It is one of its kind. It's an institutional grade consortium chain or a permission chain using zkSync Previdium. It's the first chain using Previdium, and it is part of Project Guardian, with Deutsche Bank being the first part of it. It is built using zk chain, a zk rollup with a Validium setup or a Previdium setup. So Validium setup in a rollup is where you have control over your data, and Previdium is where you have even better compliances of your data. Then another example is Binary Network, which is a startup in the telecom space. They already have more than 40 to 45 million wallets. And then there are a lot of different kind of apps are being launched on the network. It is has been built using Avalanche L1. It's a complete sovereign L1 chain, permissionless, and different users can join the chain, and already most of their wallet customers are joining it. And as they partner with more and more telecom players, we are going to see much, much more traction. The best part is using Avalanche L1, scalability is not a challenge. It's a very lean stack, and you can launch a chain which can scale to any numbers. Then we have CodeNet, which is again, it's more of a between permissionless and permission. It's a digital product passport use case in the automotive space, where they are tracking each and every automobile and their maintenance history and their logs, etc., using blockchain, bringing transparency for not just the vehicle owners but also the insurance players and other participants in the automotive industry. It again has been built using Avalanche L1 with some permissioning in place, especially ensuring the privacy of data like the PII data and so on and so forth. Then we have Roar, which is it's built on OP Stack. It is a layer 2 optimistic rollup, settling all their transactions on Ethereum chain. And they have a very strong ecosystem. It's a DeFi ecosystem that they have launched, including NFTs, including DEX, and cross-chain interoperability of liquidity. And then we have Skynet, which is built using Arbitrum Orbit, another optimistic rollup stack. It's a layer 3 chain. So when we say layer 3, that means your settlement layer is layer 2. So in this case, Arbitrum Nova is the settlement layer, and Skynet is a Orbit layer 3 chain. And it is purpose-built for AI agent communication, designed for high-speed coordination and low-latency task execution. So key takeaways, if you talk about, so one, all app chains need a production-ready, highly scalable infrastructure, and that kind of mindset is required. So just imagine in Web 2, when you are launching an enterprise-grade application, infrastructure becomes super, super important. Similarly, when you are launching an app chain, your infrastructure requires a clear strategy, clear planning, and clear execution. And then, cross-tech experience is critical. So at times, we provide a massive consulting on which stack to choose, depending on your use case, depending on your ecosystem preference, depending on what kind of smart contracts you want, any language preferences, etc. Choice of a right stack becomes very, very important, and that requires gaining expertise across different stacks. And then bringing automation, 24/7 monitoring, again becomes very important, so that you can spin up test nets on the fly, test it out, and ensure that your infrastructure is highly reliable, at the same time high performing. And then having sound monitoring in place, so to ensure the longevity, performance, and user experience. And so this is these are some of the key takeaways based on our experience of running so many app chains and rollups today. If you want to build your own app chain, Zeeve provides a complete automated platform to launch your testnets in just a few clicks, and at the same time, a complete platform to launch your production-ready mainnets or production app chains or rollups. It includes, helping you onboard, to monitoring, to provide third-party integrations with 60 plus partners that we have, and then ongoing monitoring and management of it to ensure that your chain is top-notch and up and running. So this is all which I wanted to cover. If you have any questions, you can cover on.